Well, আমি লাষ্ট টাইম কলিশ্যন থিয়ৰীৰ বিষয়ে ডিছকাছ কৰিছোঁ। কলিশ্যন থিয়ৰীত কি আছিল? Suppose this is a gas and this is another gas. Okay, so reaction between two gases, okay, to form product. So according to collision theory, how A and B react? Answer is that there is collision between A molecules and B molecules. And as a result of collision between A and B molecules, they acquire activation energy to form the product. Okay, so that is the basic idea of collision theory. আৰু collision theory to কাৰ ক্ষেত্ৰত applicable হয়? Collision theory is applicable to gas phase bimolecular reaction. Bimolecular means order of the reaction is 2. So দুটাৰ মাজত collision হৈছে, E আৰু B দুটাৰ মাজত collision হৈছে, so order of the reaction is 2. That means it is a bimolecular reaction. Okay, now today we will talk about unimolecular reaction. Theory of unimolecular reaction, and that theory was given by Lindman. So Lindman's theory of unimolecular reaction. So what we are going to discuss? We are going to discuss about Lindman's theory of unimolecular reaction. Okay, so that theory was given in 1922. Okay, and the name of the scientist is F.A. Lindman. Okay, he gave this theory of unimolecular reaction. Now you see, okay, যদি আমি এই ৰিয়েকশ্যনটো চাওঁ, there is collision between A and B molecules. So order of the reaction is 2. That means this is a bimolecular reaction. Now suppose we have only one reactant. Now if we consider collision like this, then obviously rate of reaction will be proportional to concentration of A square. So again it will be a bimolecular reaction. That means order of the reaction will be 2. Okay, that means we cannot straightway say that the reaction has taken place due to collision between two A molecules. Okay, গতিকে আমি এনেকৈ ক'ব নোৱাৰোঁ যে দুটা A মলিকুলৰ মাজত collision হৈছে, collision হোৱাৰ কাৰণে প্ৰডাক্টটো ফৰ্ম হৈছে, কাৰণ তেতিয়াহ'লে কি হ'ব? R will be proportional to A square, A plus A, 2A, A square. That means again order of the reaction will be 2, so it will be a bimolecular reaction. Okay, আৰু unimolecular reaction যদি হ'ব লাগে কেনেকুৱা হ'ব লাগিব? We have to write like this. That may be unimolecular. That means order of the reaction will be 2. So if we write like this, order of the reaction will be 2. That means bimolecular. But if we write like this, then it will be unimolecular, because R will be proportional to concentration of A. Okay, R will be proportional to concentration of A. That means order of the reaction is 1, so it is unimolecular. Okay, now the mechanism of this unimolecular reaction, was proposed by Lindman. What is the mechanism of this unimolecular reaction? So Lindman proposed like this. Say step 1. In the first step, what happens? A plus A, they react, okay? And this is a reversible reaction. This is the rate constant of the forward reaction. This is the rate constant of the backward reaction. And as a result of this collision, we get this. Now, what does this mean? A star. What does A star means? It means that this is the energized molecule. This is the as a result of collision between two A molecules, this molecule is energized. That means now it has sufficient energy. It has acquired the activation energy to form the product. Okay, মই আকৌ এবাৰ কৈছোঁ দুইটাৰ মাজত কলিউশ্যন হৈছে, কলিউশ্যন হৈ এই দুটা ফৰ্ম হৈছে। ইয়াৰে ভিতৰত এইটোৱে কি বুজাব? এ ষ্টাৰে কি বুজাব? যে কলিউশ্যনৰ ফলত এজ এ ৰিজাল্ট অফ কলিউশ্যন this molecule has acquired activation energy. Okay, this molecule has acquired activation energy, but this species has acquired activation energy. আৰু activation energy পালেহে product form কৰিব. Okay, now what is the step 2? In step 2, that energized molecule, it forms the product. Okay, so these are the two steps proposed by Lindman for this unimolecular reaction. Okay, but mind that, and you perhaps you know about activated complex. Okay, this is not the activated complex. A star is not the activated complex. It is a species which has acquired activation energy, and after getting activation energy it forms the product. কাৰণ activation energy পালেহে product form কৰিব পাৰিব. This is the mechanism proposed by Lindman. Okay, now from this we can think that this is the intermediate. A star is the intermediate. Now if we write d A star by dt, if we write this, definitely you remember this, how to write. So from these two steps I am to write d A star dt, that means d intermediate dt. Okay, rate of formation of intermediate A star. So আমি যদি লিখো কি হ'ব, ইয়াত কি হৈছে forward reaction, this is formed, so it is plus, so k1 A square, A plus A square, 2A A square. Now at the same time backward reaction. So backward reaction to hole ki hobo, concentration of A star will decrease, that means minus k minus 1. And what is the reactant for the backward reaction? Reactant for the backward reaction A star A. So this will be A star into A. Now this reaction, this is the reactant. So concentration of A star will decrease. So again minus K2 A star. Okay. Now according to steady state concept. Now you remember steady state concept, steady state theory. Steady state theory. According to steady state concept, d intermediate dt equal to 0. That means d A star dt, that is equal to 0. Okay, 0. So this is the equation number 1. So from 1 what we get? K1 A square equal to K minus 1 A star A plus K2 A star, or this is equal to I can take A star common. I can take A star common, so this will be K minus 1 A plus K2. Hence A star will be equal to uh, K1 A square K minus 1 A plus K2. So we are getting this. Okay. Now what happens is that from this mechanism, what we find, A star is being formed at the same time. A star and A, they combine to form back the reactant. So reversible reaction, you know this. Okay. Now you see, say here the rate from this reaction, say this is the reaction, say let me call it 1, this is 1, this is say 2, okay, this is 2. So from 1 rate of reaction, that will be equal to minus dA by dt, and you see uh, um, this is equal to now if we think that this is the slowest step in the mechanism, that is rate determining step. Okay, if this is the rate determining step, slowest step, then the rate of the reaction will be equal to K2 A star. Okay, you remember about rate determining step, slowest step is the rate determining step. So if we consider this to be the step 2 to be the rate determining step, then rate of reaction will be equal to this. Hence, if we put this value of A star, so we will get K2 K1 A square. We are putting the value of A star. So we will get K minus 1A plus K2. That means rate of the reaction is this. So this is say number 3. Rate of the reaction is 3. Now if we assume that K minus 1A is very greater than K2, okay, that means rate of this reaction, rate of this reaction, rate of this reaction is much higher than the rate of this reaction. That means this is the slow reaction. This is the slow reaction, rate constant is less. This is fast reaction, rate constant is more. Okay. So if we assume that, then what we can write? We can write that k minus 1a plus k2, that is approximately equal to k minus 1a. Okay. In that case r will be equal to k2 k1 a square, then k minus 1a, and that is equal to k2 k1 k minus 1a, and that is equal to, say, some constant k e. That is, the reaction is first order, unimolecular. Reaction is first order, that is, order is 1, so hence unimolecular reaction. Unimolecular reaction. But we can consider another case also. That is, if K2 is much higher than this, then obviously what we get? R equal to, okay, R equal to K2 K1 a square by K2. We can write this. So that is equal to K1 a square. That is, this is second order. That means bimolecular reaction. So order is 2. That is bimolecular reaction. So you see, bimolecular reaction. So you see, so depending on the conditions, we will get unimolecular reaction as well as bimolecular reaction. Okay, bimolecular reaction. So and this is called the low pressure limit. This is called the low pressure limit. Low pressure limit. And this is obviously high pressure limit. This is high pressure limit. High pressure limit. Okay, high pressure limit. So at high pressure, what happens? The rate of backward reaction is much higher. So we get unimolecular reaction. But at low pressure, that means volume is more. Low pressure means volume is more. So we get so at high pressure, volume is less. So then what happens? This is formed, it immediately reacts. Okay, it reacts to form back the product. And when volume is less, high pressure volume is less, rate of backward reaction is more. Okay, so we get this. So this is Linman's theory of unimolecular reaction. Okay, so at high pressure we get the unimolecular reaction, but at low pressure we get the bimolecular reaction. Okay, so this is. Now let me start our second unit. That is, second unit is catalysis. So we have completed the first unit. Now we will start the second unit. Okay, that is catalysis. And catalysis, some reactions, many reactions in fact, many reactions take place in presence of catalysis, in presence of catalyst. Okay, in organic chemistry you have encountered so many reactions. Organic chemistry বহুত reaction পাইছা, যিবিলাক reaction catalystor presence of হয়. Reactions taking place in presence of catalyst are called catalytic reactions. Reactions taking place in presence of catalyst are catalytic reactions, and the phenomenon is known as catalysis. Now, what are the general characteristics of catalyst? General characteristics of catalyst. Of catalyst or catalytic reactions. Catalytic reactions. Okay. General characteristics of catalyst or catalytic reactions. Number one is that the amount of catalyst. You know this. You already know this. Amount of catalyst remains the same. Remains the same. That means amount of catalyst before the reaction equal to amount of catalyst after the reaction. Amount of catalyst before the reaction is equal to amount of catalyst after the reaction. That means amount of catalyst does not change. But you remember, amount of catalyst does not change. It does not mean that the catalyst does not take part in the reaction. Catalyst takes parts in the reaction. Catalystor amount to একে থাকিব, তাৰ মানে এইটো নহয় যে catalyste reactionত অংশগ্ৰহণ নকৰে. That is not correct. What is correct? Catalyst does take part in the reaction, though the amount of the catalyst remains the same. Okay. Second thing is that only a small quantity of the catalyst is required. Of the catalyst is generally needed. So it is not that you need a huge amount of catalyst, but in fact you need a small quantity of the catalyst. But there are some reactions. This is the general case. Generally, small quantity of catalyst is required, but there are some reactions, mainly some homogeneous reactions. Now, what is homogeneous reaction? I will talk you. For some homogeneous reactions, what happens? Rate of reaction is proportional to the concentration of catalyst. That happens. That happens. For some homogeneous reactions, that happens. Rate is proportional to the concentration of catalyst. Now, in that case, what happens? You need more quantity of the catalyst. In such a case, where the rate of the reaction is proportional to the concentration of catalyst, you need large amount of catalyst. Otherwise, generally you need a small quantity of catalyst. Okay. Now number 3 is that catalyst does not alter the position of the equilibrium. Of a reaction. It means that you can use the catalyst. If you use the catalyst, the speed of the reaction will increase. Okay, before that, what is a catalyst? Which can increase the rate of reaction. Okay, we do not say that substance which can decrease the speed of reaction is catalyst. That is not correct. What is correct? Catalyst is a substance which can increase the rate of reaction. Okay, so catalyst increases the rate of reaction, no doubt, but it does not change the value of the equilibrium constant. It does not change the value of the equilibrium constant, because catalyst will increase the speed of the forward reaction. At the same time, it will increase the speed of the backward reaction. Okay, catalyst will increase the speed of the forward reaction. At the same time, it will increase the speed of the backward reaction to the same extent. Forward reaction speed jiman gun बढ़াব, backward reaction speed himan gun बढ़াব. সেইকাৰণে equilibrium constant value to change নহয়. It remains the same. Okay. Fourth, catalyst does not initiate the reaction. Catalyst does not initiate the reaction. Catalyst reaction to আৰম্ভ নকৰে. Okay, catalyst reaction to আৰম্ভ নকৰে. ই মাত্ৰ reaction speed টোহে বঢ়াব. Okay. 5 is that action of catalyst is highly specific. Action of catalyst is highly specific. Now, what does it mean? Highly specific. What does it mean? That means for a particular reaction, you need a particular catalyst. Okay? তুমি অর্গেনিক কেমিষ্ট্রিত দেখিছা বেলেগ বেলেগ ৰিয়েকশ্যনৰ কাৰণে বেলেগ বেলেগ কেটালিষ্ট ইউজ কৰে. এনেকুৱা নহয় যে এটা কেটালিষ্টে সব ৰিয়েকশ্যনে স্পীড আপ কৰিব. ইট ইজ নট লাইক ডেট. অ'কে, সে ফৰ এক্সাম্পল দিছ ৰিয়েকশ্যন. This reaction is catalyzed by iron. This reaction is catalyzed by iron. Okay? It is not that iron can catalyze all the reactions. So it is highly specific. Okay? So action of catalyst is highly specific. Okay? Similarly, in our body, so many reactions are going on. Every moment, so many reactions are going on. Okay? And enzymes in our body, enzymes are the species which act as catalyst. Now, So many different types of reactions are going on in our body. Now, for a particular reaction, a particular catalyst. Okay, for a particular reaction, a particular catalyst. No? For example, glucose. Glucose is catalyzed to alcohol, and plus carbon dioxide, and this is catalyzed by an enzyme called zymase. So zymase can catalyze this reaction. It is not that zymase can catalyze all the reactions. So for a particular reaction, a particular catalyst or enzyme. So it is called action of enzyme is highly specific. Number 6 is that catalyst cannot alter the nature of the products of the reaction. It is obvious, catalyst নাথাকিলে যিটো product হ'ব, catalyst থাকিলেও product সেইটোৱে হ'ব. So it cannot change the nature of the product. Okay. Now, number 7 is that a catalyst may be poisoned. A catalyst may be poisoned. May be poisoned by certain substances. Okay, and these may be some impurities. Okay, these may be some impurities which may destroy. Poison means destroy, which may destroy the action of the catalyst. Okay, so these are called catalytic poisons, catalytic poisons which can destroy, which can affect the action of the catalyst. There are some substances. Okay, so these are the general characteristics of catalytic reactions. Okay, now we have already said that there may be two types of catalysis. Okay, catalysis may be of two types. One is homogeneous. The other is heterogeneous. Two types of catalysis. Definitely you have heard about this. So catalysis দুই ধৰণৰ হ'ব পাৰে, homogeneous আৰু heterogeneous. Now, what is homogeneous catalysis? What is homogeneous catalysis? Reactant and catalyst. Reactant and catalyst are in the same phase. If reactant and catalyst are in the same phase, okay, same phase, then we say that it is homogeneous catalysis. Okay. Now, what is phase? It is not state. Phase is not state. Okay. Suppose you are consider air. Okay. So there is nitrogen, oxygen, carbon dioxide, so many gases are there. So air is a mixture of so many different gases. Okay. So now here you see state is gaseous state, one state. Now here phase is also one. You mix any number of gases which do not react among themselves. You mix any number of gases, you will get just one phase. তুমি যিমানটা গেছ লগ নলগোৱা কিয়, যদি গেছকেইটাৰ মাজত ৰিয়েকশ্যন নহয় তেনেহ'লে এইটো ফেজ এটাই হ'ব। এনি নাম্বাৰ অফ গেছ, দুটা দুটা গেছ লগোৱা, তিনিটা গেছ লগ লগোৱা, যিমানটা গেছ লগ নলগোৱা কিয় তোমাৰ ফেজ এটাই হ'ব। গতিকে হিয়াৰ ষ্টেট ইজ ওৱান, ফেজ ইজ অলছ' ওৱান। ষ্টেট ইজ গেছিয়াছ ষ্টেট, phase is also gaseous. Okay, but in case of liquid, you see, say you mix say water and alcohol. Again liquid state is one liquid state, and water and alcohol, they are miscible. Water and alcohol mix হয়, they are miscible. ওকে, গতিকে আমি লিকুইড লগ লগাইছোঁ যিবিলাক লিকুইড মিছিবল হয়। মিছিবল হ'লে দিছ ইজ ওৱান ফেজ। ফেজ ওৱান, number of phase is one. But you mix water and oil, do they mix? Water and oil mix hobone? Mix নহয়. So in that case there will be two phases. So phase will be two. Now state one, liquid state, state one, but phase two. তাৰমানে কথাটো হ'ল কি, তুমি যিমানটা লিকুইড মিক্স নকৰা কিয়, যদি লিকুইডকেইটা মিছিবল হয় তেনেহ'লে ফেজ ওৱান। চিমিলাৰলি তুমি যিমানটা লিকুইড মিক্স নকৰা কিয়, লিকুইডকেইটা যদি মিছিবল নহয় তেনেহ'লে নাম্বাৰ অফ ফেজ উইল বি ইকুৱেল টু নাম্বাৰ অফ লিকুইডছ। ওকে, আমি যিমানটা লিকুইড লগ লগাওঁ ফেজ সিমানটাই হ'ব যদি মিছিবল নহয়। ওকে, আৰু ইন কেছ অফ সলিড হোৱাট হেপেন্স? ইচ সলিড ইজ এ ডিফাৰেণ্ট ফেজ। তুমি এটা সলিড থাকিলে ওৱান ফেজ, দুটা সলিড যদি মিক্স হৈ থাকে টু ফেজেছ, তিনিটা সলিড মিক্স হৈ থাকিলে থ্ৰী ফেজেছ এণ্ড ছ' অন। ছ' ইচ সলিড ইজ ওৱান ফেজ। Okay, that is phase. So you will study about phases when you study about phase rule. Okay, well, now you see example of homogeneous reaction. Okay, suppose we have this reaction, sulfur dioxide, this is gas, plus oxygen, this is gas. So in this reaction nitric oxide gas, okay, so 2SO3. So reactant gas, catalyst gas, আৰু আমি কি ক'লোঁ, you mix any number of gases, so that will be one phase. So reactant and gas, they are in one phase. So this will be homogeneous catalysis. Okay, reactant, not product, reactant and gas, they are in the same phase, because if we mix any number of gases, that will be one phase. So this is example of homogeneous catalysis, and this is of course gas phase reaction. Similarly, say hydrolysis of ester, this reaction may take place in presence of acid. Okay, you will get this and R-OH. So hydrolysis of ester in presence of acid. Okay, again this is homogeneous catalysis in liquid phase. This is liquid, this is of course liquid, and acid, suppose we are taking HCl, so this is dissolved in water. Okay, so one phase, গোটেইকেইটা লিকুইড মিক্স হৈছে, গোটেইকেইটা লিকুইড মিক্স হোৱা মানে কি we are having one phase. Or say inversion, sucrose C12H22O11, hydrolysis of sucrose in presence of acid, you will get glucose and fructose. You will get glucose and fructose. Okay, glucose and fructose. So again acid dissolved in water, this is dissolved in water, so reactant and catalyst, they are in the same phase, mix hoise, they are in the same phase. So this is also example of homogeneous catalysis. Okay, now heterogeneous catalysis. Heterogeneous catalysis. Now what happens here? Reactant and catalyst, they are in different phases. Reactant and catalyst, reactant and catalyst are in different phases. Different phases. Okay, so this reaction, same reaction, so SO2 gas, same reaction. This same reaction can be done in presence of vanadium pentoxide. This is solid. This is solid. Solid means it is a different phase. Okay, solid means different phase. So reactant and catalyst, they are in different phases. So this is example of heterogeneous catalysis. Similarly, I have written this reaction you see, this reaction, reactant gas, nitrogen, hydrogen, iron, solid. So reactant and catalyst are in different phases. So this is also example of heterogeneous catalysis. So two types of catalysis we have seen. Then there may be another thing which is called autocatalysis. Autocatalysis. Autocatalysis means if the product of a reaction acts as the catalyst. Okay, that is called autocatalysis. If the product of a reaction, if, let me write, if one product of a reaction acts as catalyst, then it is called autocatalysis. For example, say oxalic acid C2H2O4, potassium permanganate KMnO4, they react in presence of acid to form K2SO4 plus MnSO4 plus CO2 plus H2O. This is the reaction. Okay, this is the reaction. Now in this reaction, manganese sulfate, it is a product of the reaction. It is a product of the reaction and it acts as the catalyst. This product acts as the catalyst. বুঝছে নে? আৰু সেইটো তুমি নিজে দেখিবা, তুমি বোধহয় টাইট্ৰেশ্যন কৰিছিলা অক্সেলিক এচিড আৰু পটাছিয়াম পাৰমেংগেনেটৰ মাজত টাইট্ৰেশ্যন কৰিছিলা। তুমি অক্সেলিক এচিড 25 cc উলিয়াই লোৱা, পাৰমেংগেনেট বিউৰেটত লোৱা ফাৰ্ষ্ট ড্ৰপ পাৰমেংগেনেট দিলে ইয়াৰ কালাৰটো নোহোৱা হয় কিন্তু কিছু সময় পিছত নোহোৱা হয় কিন্তু সেকেন্ড ড্ৰপ পাৰমেংগেনেট দিলে কালাৰটো ইমিডিয়েটলি নোহোৱা হয় হেতু কি হয় ফাৰ্ষ্ট ড্ৰপটো দিওতে কেটালিষ্টটো নাছিল কিন্তু সেকেন্ড ড্ৰপটো দিওতে কেটালিষ্টটো আহি গ'ল okay so this is an example of auto catalysis okay so next we will discuss about homogeneous catalysis an example of homogeneous catalysis is acid base catalysis okay so there are so many reactions which are either catalyzed by acids or bases so many reactions are there okay for example hydrolysis of ester this may be catalyzed by acid or this reaction may also be catalyzed by base and hydrolysis of ester by base is called saponification okay so there are so many reactions once again you have found in organic chemistry বহুত reaction পাইছা কোনবাবোৰ ৰিয়েকশ্যন হয়তো এচিডৰ দ্বাৰা কেটালাইচিছ হৈছে আন কিছুমান ৰিয়েকশ্যন বেছৰ দ্বাৰা কেটালাইচিছ হৈছে so many reactions are there okay suppose এটা ৰিয়েকশ্যন এচিডৰ দ্বাৰা কেটালাইজ এচিড মানে হাইড্ৰনিয়াম আয়ন suppose one reaction is catalyzed by acid okay then rate constant of that reaction we can write it like this we have one reaction which is catalyzed by acid hydronium ion okay so rate constant of this reaction can be written like this this K naught plus KH3O plus and this it can be written like this okay so what is K naught this is the rate constant of the uncatalyzed reaction there is no catalyst rate constant is of the uncatalyzed reaction okay and this is the rate constant of the catalyzed reaction or this is called the catalytic constant this is also called catalytic constant not rate constant this is called catalytic constant okay catalytic constant of hydronium ion this is the rate constant of the uncatalyzed reaction this is the catalytic constant so if the reaction is catalyzed by hydronium ion then rate constant of this reaction can be written like this and in that case this will be called specific acid catalysis this is called specific acid catalysis okay now say another case maybe that is this is number 1 this is specific acid catalysis okay This is number one. Number one. Number two may be general acid catalysis. Acid catalysis. So this means that suppose the reaction is catalyzed by different acid, say A1 acid, A2 acid, A3 acid, and so on. Suppose this particular reaction is catalyzed by so many different acids. These are acids. So this is one acid, this is another acid, and so on. So reaction is catalyzed by so many different acids. Then we will call it general acid catalysis. So in that case, rate constant of this reaction will be equal to, again this is rate constant of the uncatalyzed reaction plus this will be say K1 concentration of A1 plus K2 concentration of A2 and so on plus so on. So we can write it like this: K naught plus summation Ki Ai. Okay, we can write it like this. And this is for acid. Let me write it this. A for acid. So this is the rate constant of the uncatalyzed reactions and catalytic constant for number 1 acid, catalytic constant for number 2 acid, and so on. In general, we can write it like this: summation of this. This is general acid catalysis. And number 3, here A1, that is proton donor. Now according to Bronsted-Lowry concept, what is an acid? According to Bronsted-Lowry concept, what is an acid? Acid is a substance which can donate a proton. Bronsted-Lowry concept mote, what is acid? Acid is a substance which can donate a proton. Je proton donate koribo pare, it is a acid. Okay, so these are acids. Okay, let me write it I. So these are acids which can donate proton. Okay, proton. Now electrophilic catalysis. Now you see, according to Bronsted-Lowry concept, acid is a substance which can donate proton. Which can donate proton means which can donate positive charge, proton positive charge. Now according to Lewis concept, what is acid? Acid is a substance which can accept a pair of electrons. Now, acid accepts a pair of electrons. According to Lewis. Proton donate koribo. Proton donate kora mane electron ki koribo? Accept koribo. Na? Gotike aru which accepts electron is electrophile. যিয়ে ইলেক্ট্রন গ্রহণ কৰিব, ইলেক্ট্ৰোফিলিক. ওকে, যিয়ে ইলেক্ট্ৰন গ্ৰহণ কৰিব সেইটো হৈছে ইলেক্ট্ৰোফাইল. ওকে, so in this type of catalysis, the reaction is catalyzed by Lewis acids, that means electrophiles. Reaction is catalyzed by Lewis acid. Reaction is catalyzed by Lewis acid. Lewis acid, that is electrophile. Okay. Similarly, number 4 is specific base catalysis. Specific base catalysis. Base catalysis. That means reaction is catalyzed by hydroxide ion. If the reaction is catalyzed by hydroxide ion, then it is called specific base catalysis. Reaction is catalyzed by hydronium ion, specific acid catalysis. Okay, specific base catalysis. In this case, rate of reaction will be equal to, again, rate constant uncatalyzed reaction, then catalytic constant this, catalytic constant this, specific base catalysis. Similarly, we will have general base catalysis. General base catalysis. Okay, that means the reaction is carried out in presence of different bases. These are the bases. The reaction is carried out in presence of different bases B1, B2, B3, etc. So in this case, rate constant will be equal to K naught plus summation of Ki, this is base, okay, base, and Bi. Just as in case of acid catalysis, general acid catalysis. This is general base catalysis. Okay. So next is nucleophilic catalysis. So you know base ki koribo? Base will donate a pair of electron. So we will get next is 6. Okay, we will get nucleophilic catalysis. Nucleophilic catalysis. Okay, nucleophilic. That means nucleus loving. That means positive charge loving catalysis. So here catalyzed by Lewis bases. Catalyzed by Lewis bases. Okay, Lewis bases. Catalyzed by Lewis bases. Okay. Now let us consider general acid base catalysis. General acid base catalysis. Acid base catalysis. So we assume that the reaction is catalyzed by, say, let us consider this is the reaction. The reaction is catalyzed by so many acids and so many bases. So many bases. Okay, in that case, rate constant will be equal to K naught plus summation Ki A, and this is Ai summation Ki, say B base Bi. Okay, so we can write like this. That means if the reaction is catalyzed, we assume this reaction is catalyzed by so many acids and so many bases at the same time. So we can write like this. This is called the general acid base catalysis. Rate constant for general acid-base catalysis. Now, what is the mechanism of acid catalyzed reaction? Mechanism of acid catalyzed reaction. Acid catalyzed reaction. Okay. Now, what is the first step? Okay, what is the first step in the mechanism? What is the first step in the mechanism? Now, in the first step of the mechanism, the substrate reactant, it reacts with the acid. It reacts with the acid to form say K1, K minus 1 to form this. So this is the first step. This is the first step in the mechanism. What is the step 2? In step 2, this breaks down. This may react with the solvent. This may react with the solvent to form the product. Plus water. Not water, plus catalyst. Because we have to get back the catalyst. Amount of catalyst remains the same. So whatever catalyst has been used in the first step, the same amount of catalyst we have to get back. Okay. So these are the two steps. Okay. Now this mechanism is called protolytic mechanism. This mechanism is called protolytic mechanism. Okay. Now in protolytic mechanism, what happens? This species reacts with the solvent, that is water. Okay, it reacts with the solvent, that is water. But we may have another type of mechanism which is called prototropic mechanism. I'll talk about this. So example of this reaction is, say, hydrolysis of cane sugar. Okay, hydrolysis of cane sugar, say S equal to, say, this C12H22O11. Hydrolysis of cane sugar. So S will react with this first to form this SH. Okay, then in this second step, this will react with water to form back. Now, if sucrose undergoes hydrolysis, what we get? We get glucose and fructose. Glucose plus fructose plus H3O plus. Okay, because sucrose may undergo hydrolysis in presence of acid. So how this reaction takes place? First, sucrose reacts with the catalyst to form this species. In the next step, it reacts with water, that is protolytic mechanism to form back this. Okay, now here this proton has been transferred to water. This proton has been transferred to water, that is solvent. So it is called protolytic. Now if step 2 is like this, so proton transfer has taken place. not to the solvent, not to the solvent, but to some other species. This is called prototropic. This mechanism is called prototropic mechanism. Protolytic mechanism and prototropic mechanism, where proton transfer, step 2, proton transfer takes place not to the solvent water but to some other species. Okay, so some other base, it may be some base, because base will take proton, so this is called prototropic. Okay, so this is the mechanism. Now uh, we have one portion, so we will discuss about this next time. Let us stop here today. Okay, so thank you.